Video. Evaluate the following integral using an appropriate trigonometric substitution. So state the trigonometric substitution that must be applied here. Now, one thing that you need to understand is that look at the integrand. The integrand, all right, this, all right, is very important as we move from there onwards. Okay, this is very important. When you have a situation like this, where you have a squared minus x squared, you should be thinking of a trigonometric substitution. So now, which one are we going to use here? Is it cos? Is it sine? Is it what? Now, this applies for sine. Trigonometric substitution. All right? That's what that calls for. All right, let's move on. So since we remember this is the form a squared minus x squared, and anytime you have this form, you have to say x is equal to a sine theta. Now let's check ours. Ours is 9, meaning we can transform that 9 into 3 squared minus x squared, meaning this in our case changes to x is equal to 3 sine theta. This is our x. Okay, now that we know our x, we now need to differentiate this with respect to theta. So find x with respect to theta. What do you get? You get 3 cos theta d theta. Now, if that's the case, let's go back to the equation itself. Under the root, if this is the case, and we know that our x is like that, meaning we have our form like this. So this becomes 9 minus, what is x? X is 3 sine theta, then we square it, which brings us to 9 minus 9, then sine squared theta. Of course, here we can factorize, right? So we can take the 9 out, then you have 1 minus sine squared theta. Your aim is to have 1 there. It becomes easier. Now we know that from the trigonometric identity, sine squared theta plus cos squared theta, this just got 1. So from there, we can just replace, and this becomes 3, so 9. This whole thing is just cos squared theta, and everything here are squares. So this will give me 3 cos theta. So square root of cos squared and the square root of 9. We move like that. All right, let's now proceed now. We have what we need to deal with, isn't it? So we have 3 cos theta, just the inside part. All right, so we know what we have here. All right, let's go back to our integral. What are you looking at? Oh, okay, yeah. Let's now substitute everything. So our integral, you can call it I, will be equal to x squared. Remember, if I square x, what do I get? I'll get, it's like I'm squaring this guy here. I'll get 9 sine squared theta over root of, this root has been evaluated into 3 cos theta. What is dx? This dx. Dx was 3 cos theta d theta. So these cancel, we remain with the integral. First, we can take the 9 out. The 3 and 3 cancel. Cos and cos cancel. We make the integral of sine squared theta d theta. Now, of course, we know the identity. All right, we can use half angle identity here. Again, we are back to half angle identities there. It's very important. You see? So it's still going back there and there. So the half angle identity for sine squared theta is what? Give me, it's 1 minus cos 2 theta over 2. You go back to trigonometric identities. Very important. We cannot just substitute there. So end up having 9, yeah. So because of these two, you can just say 9 over 2, integrating what? 1 minus cos 2 theta. No need of over. Yeah, just cos 2 theta d theta. We couldn't just go on and integrate that. It would be very complicated, ladies and gentlemen. So we have to find a way of manipulating so that we can write it in half angle identity. All right. So if we integrate whatever that results there, what do we get? integrate with respect to theta. So 1 becomes theta, so this becomes 9 over 2 theta. Then minus, this becomes 9 over, remember, this 2 when you integrate, it will become over 2. So but another 2 here, that will be 4. Then sine 2 theta plus c. But remember that our question was actually in terms of x. So how do we take it back in terms of x? All right. We know from the word, because this is now they are saying express the final answer entirely in terms of x. So we know that x is actually 3 sine theta. Yeah. Meaning sine theta is equal to what? If I divide by 3 here, it will be x over 3. X over 3. So now let's just take it back there. Meaning our integral, or also theta, will be equal to sine inverse of x over 3. At least we have that, we have that, we have that. Let's go back into the equation. All right. Now look here, we've got sine 2 theta. Sine 2 theta is also a problem there. Now we know from the double angle identity that sine 2 theta is what? It's 2 sine theta cos theta. At least we've established something there. So we know what cos is. So we know what sine theta is. What about cos? Therefore, what will be cos theta? Remember, if I draw a triangle, okay, this is theta. What is sine? Sine is x over 3. Now, in terms of sides, sine is opposite over hypotenuse. So the opposite is x, the hypotenuse is 3, meaning the adjacent is that root there. Remember the root? 9 minus x squared. That becomes the root. So this is our adjacent. And we know that cos is adjacent over hypotenuse. So adjacent is x and hypotenuse, adjacent is 9 minus x squared over hypotenuse is 3. So this becomes our cos theta. Now we can now go back and substitute. I'm just going to substitute here, meaning sine 2 theta, it will be 2 sine theta. Now check out, I know what sine theta is. Sine theta is x over 3. And now cos theta is root of 9 minus x squared over 3. At least I've now transformed this into this. We can now go back and rewrite our integral. Our integral, which is 9 over 2 theta minus 9 over 4. Then we have sine 2 theta can be integrated into 9 over 2. What is theta? Theta is actually sine inverse of x over 3. Then minus 9 over 4. What is sine 2 theta? Sine 2 theta is actually there, which is just 9 minus x squared over 3. Right? Just a minute. Yes. Okay. No. Taibarako 2 x over 3 multiplied by 9 squared over 3, like this. All right, now it's complete. We can now just further simplify this, which will give us 9 over 2 sine inverse of x over 3. Now this can multiply this, and this can multiply. This is like 9 times 4. That's like 36. Right? And again, there is 9 times 2, which is 18. So this will give us just x there. 9 minus x squared over. Remember that the down part is 36 and the upper part is 18. And 18 can go into 36 twice. Plus c. That is the answer. Wonderful.